This is RD Sharma solution we are taking, and probability is the chapter. Exercise is 4th. There is an urn containing 4 red and 7 blue balls. These are blue balls. 2 balls are drawn at random with replacement. Whenever we talk about replacement, we are talking about independent events. When it is without replacement, that is coming into the conditional probability. Find the probability of getting 2 blue balls. So the probability, we need first blue ball. Then the probability we are taking, the second one is second blue ball. Let's call it as PA, the other one as PB. So we need to find out PA intersection B. The first blues and the second blue. Now this comes out to be PA multiplied by PB. Why? I told you that with replacement means the events are independent of each other. So we have a box here. In this box, there are 4 red balls and 7 blue balls. So the probability will become what? First blue, second blue, they will remain the same just because the replacement is guaranteed. So this PB1, which is PA actually, and PB2, which is PB actually, just to show you that blue 1 and blue 2. So the 11 remains in the denominator because it is the sum total of that ball. So total number of cases is 7 plus 4, that is 11, and total number of favorable cases are 7 and 7 in both the cases because there are 7 blue balls. So PA comes out to be 7 by 11 and PB also comes out to be 7 by 11. So this becomes 49 by 121. Now this is how it will be done. So this is 22.1, 22.2 and now 22.3. That means this question will also follow the same scheme or same approach. An urn contains 4 red and 7 black balls. Find the probability of getting 1 red and 1 blue ball. Let's call it as a blue ball because it's quite obvious it has to be a blue ball. You cannot get a blue ball from a black ball. So there are 4 red and 7 black balls, blue balls, whichever you say. So the total will be what? 4 plus 7, which is 11 balls. 4 red and 7 blue. 11 in all. Let's not write the probability always. That means PA, PB, PC. Let's write the content here or the sentence here. Probability of 1 red and 1 blue ball. So 1 red and 1 blue. What does it mean? It means if we are considering 2 balls, the first can come red, the other one can be blue. The first one can be blue, the other one can be red. So this will go like this. Probability of red and blue, and then probability of blue and red, and then we combine them, these two. Red and blue and red, this combine these probability, that will be the actual probability. Probability of red and blue we have to find out. In both these, the denominator remains the same because the total balls are 11, which we have already computed. Red are how many? 4. 4 divided by 11. The blue are how many? 7. 7 by 11. Now since these events are done with replacement, they are independent events. So PR intersection B will be PR into PB. PB intersection R will be PB into PR. So twice of PR into PB actually we are working on. So this is 2. What is probability of B? 7 by 11. Probability of red is 4 by 11. 4 divided by 11. So this gives you 56 divided by 121. That's your final result. This is how you are going to write about it. Every time P and PB we were writing, this is a different kind of writing that you should follow or you can follow. The probabilities of 2 students A and B coming to the school in time are 3 by 7 and 5 by 7. So before going along with the question, let's just write what is being given to us. Probability that A is coming on time. This is probability first. Probability of 2 students A and B coming to the school in time are 3 by 7 and 5 by 7. A coming to the time is 3 by 7 given in the question. Probability of B coming on time is 5 by 7. So there are 2 different students. Their coming and not coming are independent of each other. So PA is 3 by 7, PB is 5 by 7. A coming in time and B coming in time, they are independent. So they are independent of each other. A and B, they are independent. If A is not coming, B will not also come, or they both will come always. It's not the case. Find the probability only one of them is coming to the school. What is the at least one advantage of coming to school in time? Coming to school in time is always the discipline, learning, and making basement for your future so that you can earn and live well. P and PB, I am just considering these 2 probabilities. What is the probability of A not coming? A is coming 3 by 7, but A is not coming. What is the probability of that? It's 1 minus 3 by 7. You know that probability of A plus probability of A bar, PA plus PA bar is equal to 1. So if A is not coming, it has to be subtracted from 1. Similarly, PB not, that the second kid is not coming, 1 minus 5 by 7. So PA and PA bar can be computed. PA bar is simply 1 minus 3 by 7. PB bar is simply 1 minus 5 by 7, which comes out to be 4 by 7 and 2 by 7 respectively. Now we need to find out the probability of only one of them coming to the school in time. That means either A comes, B doesn't come, or B comes, A doesn't come. These are A and B. A will come, B will not come as I just suggested. B will come, A will not come as I suggested. A, B not and A not B. A not and B combined and B not and A combined. So probability of A intersection B complement, A comes, B doesn't come. And probability of A not coming and B coming. When you combine these two, you will get the entire probability here. Because question is saying clearly they are independent of each other. These events have nothing in common. So since they are independent event, PA intersection B naught is PA into PB naught plus PA naught intersection B is simply PA naught multiplied by PB. And since we have already computed the values which are given and which are primary events and secondary events, we have already found out. PA is 3 by 7. PB naught is 2 by 7. PA naught is 4 by 7 and PB is 5 by 7. So it's 7 7s are 49, 3 2s are 6 and 5 4s are 20. So 26 divided by 49 comes out to be the probability of this question. And how are we going to write about it? This is in front of you. You can write it like this. Diagrammatically, you can also give some, addition to your question. Two dice. The event E, F, G, when they are thrown together, a total of 9 or more, a total divisible by 5 respectively. We have to calculate the probability of each of these three the events and decide which pairs of events, if any, are independent. For this question, the sample space is a must. In a sample space, one die 1 to 6 number, second die 1 to 6 number. Now I already told you how to write down this sample space. The first die can have 1, the first die can have 2. So just write 1, 2, 3, 4, 5, 6 in 6 rows 6 times. So just repeat 1 on the first row, just repeat 2 on the second row, 3 in the third row, 4th in the fourth row, 5 in the fifth row and 6 in the sixth row. So I'm writing it because this question demands a proper sample space, because there are some part of this sample space which can be taken for E, the other part can be taken in F and G. So the first row now write 1 2 3 4 5 6, or the rather good thing is just write 1 1 1 in the column, 2 2 2 in the column 6 times, then 3 3 3 3 in 6 times in third column, 4 in the fourth column 6 times, then 5 6 times in the fifth column and 6 in the sixth column. Now bracket and comma is your responsibility. I hope that this fixture or this composition is known to you, how the events are coming in a sample space of 2 die. Number of elements in this sample space is 6 multiplied by 6, which is 36. 6 from one die, 6 from another die, multiply them, you will get a number of sample space which is 36. Now E is saying total of 4, that is 2 values coming from different die are combined together should give you a sum of 4. So just follow this diagonal or this line. All these values in this line are going to be summing up to 4. 1 3 4, 2 2 4, 3 1 4. So number of elements in E is equal to 3. Coming to F. F is a total of 9 or more. Total of 9 or more. 9 means 3 6, 4 5, 5 4 and 6 3. So this line, which is kind of a diagonal, all these diagonal line, all these elements which crosses it are going to be the summing of total of 9 or more and the numbers which are below it. So just write all the numbers from 3 6, 4 5, 5 4, 6 3 and below. That is a triangular matrix. All the values I'm writing. You can write it any order. So I'm writing 3 6 4 5 5 4 6 3 4 6 5 5 6 4 6 4 5 6 6 5 and 6 6. In all, there are 10 elements. So number of elements in F comes out to be 10. So counted them and written them, the number of elements. Next is a total divisible by 5. So G is number divisible by 5. What are the number divisible by 5? 5, 10, 15, 20, 25, like this. But we have 6 and 6. Highest number in one die is 6 and 6 in another die. 6 plus 6 is 12. So the maximum number can come as 12. So we cannot go up to 15 or 20. We can only get 5 or 10 at maximum, which is divisible by 5, because maximum is 6 plus 6, 12. So we just cancel these out. We'll just strive or look for the numbers which are summing up in the two die as 5 or 10. So this line 1, 4, 2, 3, 3, 2, 4, 1, add them. Add these two, you'll get 5. How about 10? It's 6, 4, 5, 5 and 4, 6. Combine them. So when we combine these two, you'll get either 5 or 10. So let me write all of these. You know that you are going to use the number of elements in this G. So sample space became very important because we have actually got everything from the sample space only. So number of element in G becomes 7. This is just the beginning of the question. Now we are going to solve it. What is the probability of E? I am writing all of them because the denominator remains the same. The probability of F, the probability of G. What is probability of E, F and G? The denominator remains the same because the sample space contains 36 numbers. So all of them has 36 in the denominator. So the PE will be 3 by 36, PF will be 10 by 36 and PG will be 7 by 36. From where this 3, 10 and 7 has come? Number of elements in E, F and G respectively. So 3 by 36 is 1 by 12, 10 by 36 is 5 by 18 and 7 by 36 remains like that. Now just take these sets. E and F, anything common? I can't see anything common. So E intersection F will give you null or phi. How about E and G? Again, E intersection G will give you nothing. There is nothing common between E and G. No elements which are common. Again, a phi. Again, a null. But F and G is going to give you common values. There are certain values which are common in F and G, but they are found both in set F as well as in set G. 4 by 6, 1, 5, 5, another, 6, 4, another. So 4, 6, 5, 5, 6, 4 you got. So number of elements in F intersection G is 3, but we need to write this element. You will just say, hey, you have just written the number. I want the set because this set is important, right? So let me write this set also. Number of elements in F intersection G is 3, but what are those elements? You have to write that also. So F intersection G gives you all the values which are common in F and G, 4, 6, 5, 5 and 6, 4. So we don't have to worry about E and F and E and G intersection because they are independent event. You are getting nothing. You are getting 5. And 5 by 18 and 7 by 36 will be written for probability of F and probability G. This probability of F intersection G is equivalent to PF into PG. What is PF? 5 by 18. We already found out this one. PG is what? It's 7 by 36. So we got 35 by 648 as the result. Now this is PF into PG. How about PF intersection G? Number of favorable cases divided by total number of cases. What is the favorable cases? The favorable cases are 3. Total number of cases are 36. So 3 by 36 is equal to 35 by 648? No, they are not equivalent. When the intersection is not equal to the individual probability multiplied, we say these two are independent events. These are independent events. E intersection F was phi null. So they are independent event. E and G has nothing in common. They are null, so independent events. And PF intersection G, though they have 3 elements in common, but the probability of individual multiplication is not equal to the probability of intersection. So this F intersection G also are, or you can say F and G are independent. So this was a good question, and this is how you can do it. It can come in 5 marks, I am quite sure. So now there are 3-4 questions which wants you to write things in word or your observation in words. A and B are 2 independent events such that PA equals to P1 and PB equals to P2. Describe in words the event whose possibilities or probabilities are P1 into P2. P1 into P2 means what? PA is given as P1 and P2 is PB. What is PA into PB? It's PA intersection B. That is, They are independent event given in the question also. So P intersection B is P1 into P2. What does it mean? So P1 into P2 you can just write in simple words. A and B will occur together. A and B will occur together. So this is the word definition of P1 multiplied by P2. So this is how you are going to write it. Okay. Now same thing here, two independent events P1 and P2. P1 is PA, P2 is PB. Describe in words the events whose probabilities are 1 minus P1 into P2. So 1 minus P1 into P2 means what? Let me write 1 minus P1 and P2. In place of P1, we are writing PA. So 1 minus PA it is. P2, PB is there. So 1 minus PA is PA naught, PA bar. PB is PB only. When you multiply this, because these are independent event, we can combine this. So this is equivalent to PA bar intersection B. So how do we write this in the words? P, that is A is not occurring. This is clear. A naught means A is not occurring. A does not occur. A does not take place, but B will occur. B will take place. B will happen. A wouldn't occur. B would occur. So this is how you are going to write it. Some mathematics also you need to involve. Next one says P1, P2, PA, PB. Described in word 1 minus P1 into 1 minus P2. So I'm just writing it. I'm changing this P1 to PA, PB to P2. So 1 minus PA, 1 minus PB. Probability of A plus probability of A naught. What does it mean? It counts to 1. You add up, you will get a 1. So you have 1 minus PA, that can be written as PA bar. 1 minus PB is PB bar. So PA bar and PB bar, that is 1 minus, these are independent event. So whatever is there, A bar or B bar or A or B, intersection means just write those two on left hand side and right hand side and put a intersection sign in between. So it is PA naught intersection B naught. Now how do we observe it? Consider it as a De Morgan result. So we want A and B whole complement, but this is separate complement. A complement is different, B complement is different. Now I'm applying the De Morgan theorem. The De Morgan theorem says A bar intersection B bar, when you take the De Morgan law, this is equal to A and B, both of them with a bar, but the sign will change. The intersection will change into the union sign. So I'm writing now this PA bar intersection B bar as PA bar union B bar combined. That is A union B combined bar. A union B complement you can say. What is PA plus PA bar? It is 1. So what is 1 minus PA union B complement? It's simply PA union B. So ultimately we got PA union B. So 1 minus P1 into 1 minus P2 is nothing but PA union B. That is at least one among or one of A and B occurs. At least one of A and B should occur. A or B or both of them. So this whole question is based on this De Morgan's law. So it was a good question. You can follow this instruction to write. Next one is P1 plus P2 minus twice P1 P2. Let's write it. P1 is PA, P2 is PB, and this is minus twice of PA into PB. So P1 is PA and P2 is PB. Now let me write this negative 2 PA PB as separate minus PA PB and minus PA PB. That is, I'm writing this as negative PA PB minus PA PB, because minus 1 and minus 1 means minus 2 only. So same thing I've written. Now combine them separately. PA with PA and PB and PB with PA and PB. So just write this as PA minus PA into PB, and PB is combined with PA PB again. So I'm just writing them separately. This PB along with minus PA into PB. Now let's take out this PA outside. We get 1 minus PB inside. Here you can take PB common. So 1 minus PA remains. What is 1 minus PB? PA remains like this. PB bar, PB complement plus PB, 1 minus PA is PA bar. Now these two are independent events. When they are independent event, PA into PB bar is P happening, PB not happening, and PB into PA bar means B happening, A not happening. So just combine them. PA into PB bar is PA intersection B bar, and PB into PA bar is PB intersection A bar. So A will happen, B will not happen, and or B will happen, A will not happen. So probability becomes, in words, exactly one of them, because when A is happening, B is not happening. When B is happening, A is not happening. So exactly one of A and B will occur. Alright. In previous example, we have seen there are two kids. When A comes, B will not come, and B will come, A will not come. Same thing here. Exactly one of A and B will occur. A will come, B will not come, B will come, A will not come. You combine them. This is the word description of the probability of P1 plus P2 minus twice P1 P2. So this is the way you are going to do it. For those who are preparing for IIT, JEE, etc., this is a good question. Alright. So P only A, P only B. Both cannot come and both cannot not come. So this is all about this exercise. Thank you so much. Have a good one.